preview of what I'm going to be covering. I'm going to look at the data matrix, which I hope will be fairly familiar to you. If you know what a spreadsheet looks like, you'll understand that. I'm going to talk about coding, the general issue, that is, of transferring data from a questionnaire into numbers that we can use in a stats program or to produce some statistics. So coding fixed response questions, and the question about, or the issue about going from one question to several variables, because often that's the case, we have to do that. How to deal with open-ended questions, quite a long discussion of that. And lastly, a couple of comments, a couple of slides about how to deal with no responses and about data checking. So that's today's session about the coding, the transfer of data from questionnaires into numbers that we can use. And of course, this is really leading up to the use of SPSS next week. In fact, I'll be doing that next week. I'll be starting the sessions on SPSS, and your first exercise will include some data entry into SPSS. So next week I'll talk about how to use the software to do this. This week, the general principles about coding. Okay. I've said this before, but it won't harm repeating it a bit. In quantitative research, things are organised into variables, and because it's quantitative, those variables are measures of some kind. They're numbers, they're counts, and so on. So variables are those things which vary, and of course they normally by number or amount, and in the end we have to produce numbers, but of course they can also vary in other ways, by type or by category. And one of the issues for coding that I'm going to talk about today is how one goes from those lists of types or categories of things into numbers. It's actually pretty simple most of the time. Surveys, of course, are what we're talking about here. That's one of the major ways in which we produce quantitative data. Not everything quantitative comes from surveys. We can do experiments. We can do other kinds of data collection that might produce numbers. But I have to say, in the main, surveys are probably the predominant form of quantitative research. And I suspect many of you who do quantitative work next year in your dissertations will be doing surveys and collecting data that way. So what do we do? First of all, the first activity, of course, when you're coding, transferring from questionnaire surveys into numbers, is to identify what the variables are. Think about what they are. And the important point about this, and the key issue here, is that each variable records one fact about the respondent, and each variable takes one value for each respondent. So that's the real crucial thing, that one number we've got to get from a variable. And the problems arise when our questions start to generate more than one number. How do we deal with that is the issue. And I'll show you how to do that in just a moment. So the data matrix is one way of laying out these numbers, these single numbers for each variable, for each respondent, or for each case. And the aim is to have a data matrix. Actually, these days you don't need to do that because the program does it for you. If you're using SPSS, the stats package we're using to analyse your data, then entering the data into SPSS actually creates a data matrix. But if you're not using software, then you have to do that. And you have to do it on paper or in a spreadsheet or something. In some way or the other, you have to create that matrix. What does the matrix look like? Well, each line is a separate case. So I said it's like a spreadsheet. Each line is a separate case, or a respondent, if you like, a person who's replying to your questionnaire. And each column is occupied by a variable. So the number of variables is the number of columns you have in the data matrix. As I say, each cell contains that unique number. So here's an example of such a matrix. Fairly simple one. I've not done a lot of work on this. There's a lot more complicated examples than this, but just to start the things off, you can see I've got case numbers, and again, in SPSS, when you use it, it'll do that for you. Every line, it creates a number for you, so you don't need to do that. But if you're not using SPSS, it's a very useful thing to do. And the other thing I'd say about case numbering, I mean, whether you're entering into SPSS or into a spreadsheet, whatever, keep a case number so you know what the number of the line is. And then, this is most important, write that number on the questionnaire. If you've got printed questionnaires, which you may have, not everything's done online, sometimes you do need printed versions, but if you have a printed questionnaire, then make sure you number that as well, so you can always go back and check it. You can always go back to the original and see what it was actually saying. So it's a way of tying up the paper versions with the data matrix. So that's the case number. We don't actually use the case number in any analysis. That's just for tidiness and management, if you like. Then we have some variables, age and sex, I've just named them, and then variable 3, variable 4, and so on across the page, column after column for each of the variables. And in each cell in the matrix, you put the actual value. So we know case 1, respondent number 1, if you like, was aged 24 years. Their sex was 1. And that's another issue we have to decide. What does that mean? Well, let's say that means male and 2 means female. So in that case, we know that case 1 was male. It's arbitrary how we decide that, but I've just decided off the spur of the moment to say 1 is male and 2 is female. Doesn't matter what numbers you put there or what values you give them. But the point is we only have 2 numbers, 1 and 2, to indicate male and female. And you can see case number 3 is female. Variable 3, whatever that is, measuring, case 1 has a value of 5, and case 2 and 3 both have a value of 4, the same value as each other. And so on with variable 1. You can use 0 as well, by the way, for one of those numbers, so I've used 0 and 1 here to indicate the values, and so on. So that's the end point, that's what we want at the end, some numbers. So how do we get those numbers, and how do we do that in a consistent way that doesn't make mistakes and doesn't have problems of more than one number going into a cell? So I'm trying to have to go back to the points I made a couple of weeks ago about different kinds of data, different kinds of variables. I'm not going to spend a lot of time on this now because I did cover it last week and I will come back to it next week as well. But we have nominal, ranked, scales and measures, we have mixed types, and we have text answers. There's different kinds of ways of collecting data, different kinds of variables we might have. I'll come back to the nominal, ranked and scales several times over these lectures because actually they're important for deciding what kinds of statistical tests you should be using on those things, what kinds of stats you can produce and how you can test the relationships. So it is important to recognise that. But also it's important today to see that actually you code them in different kinds of ways. The mixed types, I think I've mentioned that before, but it's a way in which we often convert what might seem to be scales or integer measures into some kind of nominal scale. And lastly, the text answers, what's referred to in SPSS, and I'll talk about this next week, as strings, just an answer, not in any way classified. And that's the one exception to all the things I've said so far, which is about converting answers into numbers. If it's a text answer and that's all you want is the text answer, often they're longer answers too, then you keep it as text and it doesn't have a number and it's not classified. And what that means, of course, is you can't do anything with it other than read the answers. You can read the answers and gather them together, but if you want to do any statistics on it, you can't do that because it's text. So it kind of defeats the purpose, really, of this process. Actually, what I'll talk about later on is a way of converting some text answers into numbers, so you can actually count things and classify them. Okay, so let's go through each of these in turn and see what they look like on a questionnaire and how you might put numbers to them. Okay, nominal, first of all. This is where the order is arbitrary. It doesn't matter what order they come in. They're just different kinds of categories, different kinds of things. And the numbers we assign to them are arbitrary as well, although it might be worth keeping a fairly standard way of doing it, like don't use, 15 and 65 as the 2 numbers for male and female, because you'll always forget what the numbers were. Use something simple like 0 and 1 or 1 and 2, something of that kind. So this is the kind of variable we're dealing with, categorical, categorizing, what's called a nominal variable. Here's 3 examples, which I think I've given you before. But notice this time we've got numbers against them. So in this case, we've decided that where the respondent has said tick the box female, we assign a number 1 to that. Where they've ticked the box male, we assign the number 2. And where it's missing, we assign the number 99. So I'll come back to the missing values again, but quite often we assign a number like 99 or 999, whatever, some number we're not going to use in any other way, just to indicate that the value wasn't there, that it was missing. One way of checking the data quality is to go through and make sure nothing's missing at all. It's either 1, 2 or 99, so you've not actually forgotten to do anything through the thing. But it isn't always necessary. Sometimes you might find you don't need the 99, you can just leave it blank. Another example of this, the yes-no question, and there'll be quite a lot of those. In fact, just a hint to the exercise you'll be doing later on in the seminars, there'll be quite a lot of yes-no type questions, although it isn't immediately obvious that's what they are. But when you do have that, you can use yes and no, 1 and 2, or 0 and 1, whatever you fancy. And the great thing about doing that in SPSS is you can cut and paste those. So once you've done one once and set it up with those values, you can cut and paste the description into other variables. Of course, the actual values you put in depend upon what's actually replied on the questionnaire. Last example, country, UK, Ireland, Pakistan, India, other, and so on. I've put 1, 2, 3, and so on, arbitrary numbers. It doesn't matter what order they're in, the order is arbitrary. Normally, the sensible thing to do is to keep the same order as those items appear on the questionnaire, because it's much easier to transfer them and check them and so on. So whatever order you've used on the questionnaire for whatever reason, it might be alphabetical, it might be for some other reason to do with the most popular at the top and so on. Keep that order the same when you give the numbers. It makes life easy for you. But it is arbitrary in some sense. That's the very easy case, nominal. Ranks are also pretty easy. So if you've got some kind of ranked variable where things are now in order, there is an order to this, but that's about all you can say. It doesn't actually measure anything. It's just an order like winning a race or coming second, third and fourth and so on. And there are lots of examples of this in the social sciences. Status, social class and so on are very common ones. So again, use the numbers, and you might as well use the numbers in the same order as the ranking. Of course, they can go either way. You can go forwards, 1, 2, 3, 4, 5, or 5, 3, 5, 4, 3, 2, 1, or whatever, however you put them in, but keep them in the right order. So, for example, working class, middle class, upper class, 1, 2, 3, or 3, 2, 1 if you like. It doesn't matter, but keep one of those two orders because it makes sense to have it in that order. So it will go from, in this case, least affluent to most affluent kind of thing. Class of degree, again, an obvious order there. So if you have got a classification like this, then when people have ticked the box first, put a 1, that's an obvious thing to remember. But notice that 2 upper second, 3 lower second, the numbers now diverge from, it's not 2 for second, it's 3 for lower second and 4 for third. Slightly confusing, but you want a unique number for each category, so you have to do that. And again, keep the order the same as the order of the variable itself, the ranking. So in this case, the bigger the number, the lower the class of degree in that sense. Okay, so and again, a fairly easy case to deal with, and I think the advice is keep the order consistent as you do that. Just one thing to say here about these ranked things is quite often we have what are called Likert scales or Likert type scales on questionnaires, where you have a question that says, how far do you agree with this statement? And then you can strongly agree, neutral, disagree, strongly disagree. Normally have 5 points across. When you're doing those, when you're constructing those, sometimes you reverse the order of things deliberately to make the respondents think carefully about it. And you have to remember when you're entering the data to unreverse the order of things when you enter the data into your spreadsheet. I think the best way of doing that is to ignore the order completely as you enter the data, to make it simple for yourself, and then go through later on. And in the stats program, SPSS, you can change the order yourself. But it's up to you to decide how to do that. If you want to do it as you enter the numbers, you have to remember to do it. But my best advice on that is to do it later on once you've entered all the numbers. That's the only slight difficulty with ranked numbers. I thought I'd show you a couple of examples of pre-coded questions. The 2 types I've shown you already, the ranks and the ordinal and the nominal. Particularly the ranks and the ordinal, it's fairly easy to have what's called a pre-coded questionnaire. That is, the codes appear, the numbers you're going to be using to code the data appear in the questionnaires. In this case, you might ask the respondent to ring the number that applies, or perhaps underline or circle the number of the country, and you just read it off. So if they've ticked or circled or whatever, Pakistan, there's the number 3. That's the number you enter. In fact, the most common version of this you might see is the next one, where you have boxes to tick. So you tick one box, and the number is normally a small number, perhaps faintly typed against the box, and that's there simply for the purposes of coding, simply to help the researchers who are coding the data know which number it is. So if the tick appears against the box numbered 4, the number 4 is a number you have to type into the program. And actually that's not a bad way of designing questionnaires. You'll see some well-designed questionnaires that include that pre-coding on, because it makes it clear what number should be entered. It's much easier to keep it accurate and not make mistakes. So that's pre-coding. It can either be numbering the questions in that way or numbering the boxes in that way. Normally a small actually sometimes you see the numbers over on the right hand side, right over here in the margin, which is again just for the purposes of the coders putting in the data. Okay, third type of variable is the measures and scales. And this is where you have a number already. So things like height, income, family size, age, and so on. We've got a number. That's what you've asked the person for. And it's fairly simple, in this case, just to use that number. There's no reason for changing it usually. So if you've asked them what their family size is, they will tell you 1, 2, 3, 4, etc. And you just put in the number. However many people in their family, that's the number you enter. In fact, almost the simplest possible case of coding. Income per year, put that in, that number appears, and so on. So these kinds of measures, scales, the intervals and ratios are probably the easiest of all things to code because you can really only have one number there. The only difficulty comes if you decide at the point of coding to convert these measures, these interval or ratio numbers, into some kind of categorization. And I call that a mixed type. I think that's my next slide. Yes, the mixed type. Where you have categorical data, categorized data, but it actually comes from some kind of interval or ratio scale in the first place, or variable in the first place. The most obvious and most commonly used example here is age groups. Now, why might you want things in age groups rather than age? The most common reason is because you've got some existing data, perhaps some census data about the population that you're surveying, and that appears in tables by age group. So in your questionnaire, you want to be able to match up your results to that of the existing data, so you use the same age groups. And that's one reason for using age groups in that way. Another reason is because it's maybe embarrassing to ask people their age. You just want to know roughly how old they are, so that's what you ask them. Or you might want to know age groups because you're doing some kind of quota survey. And in other words, your sampling strategy means that you need to know what age groups people come into. So there are reasons for using age groups, and sometimes you might ask the age on the questionnaire and all you want to know is the age group for your data analysis. That's what I call a mixed type, because you're starting with interval, or in fact actually ratio data in this case, but you're converting it into categorical data or nominal data. But it is ordered, of course. In this case, you can use numbers to refer to the different categories. So, for example, at the bottom, the first one, the age group under 18, is given the number 1. The 18 to 24s given the number 2. The 25 to 34s given the number 3, and so on up to the 55 or greater age group, which is given the number 6. Now, the labels I've given you here, by the way, are important because when you enter the data into SPSS, you not only use the numbers to enter the data, but you can also set up the variables with those labels. So later on, when you display your results, those labels will appear on the tables and the charts and so on. So it's useful to have things like under 18 and so on appearing on your tables because you know what they mean. Having just the numbers like 1, 2, 3 and so on, okay, you can just about remember what things are, but it's an extra bit of work to do to have to convert them into the actual labels. So we enter them into the program SPSS for ourselves. But the important point I'm making here is that the fact that you need to generate those numbers from them.